Our next speaker is Mark Cochran. He's the St. Louis maintenance engineer. He was the St. Louis bridge engineer, I think, and he just got promoted. He's got 17 years of experience with construction, materials, design builds, and most recently the maintenance in 6 years in St. Louis. Thank you.
So I'm going to talk about a lot of the things you just saw, how they worked out in St. Louis on the bridges that we've used them on. And the slideshow that I put together all started with asking AASHTO for a little bit of help looking at the M-Seal that they just played the video on. St. Louis was the first in the nation to put it on a bridge. It had been used in the architectural industry for quite a while. So some of the slides are based on feedback I got from other states and kind of centered around M-Seal. But as bridge people in the room, you know that joints are extremely important. When I look at about 1,200 bridges a year, I get really tired of seeing good-looking joints with the seals falling out and try to talk about the best ways to keep them working. Joint seals leaking cause all kinds of problems. On steel bridges, it's pretty easy to see after a few years that the paint goes away, corrosion starts to happen in critical areas, the bearings freeze up, it ties into movement, and the decks start cracking, and you put forces all over the bridge that aren't meant to be there. You look up close, and the bearing stiffeners and the web at the bearing region get big holes in them pretty quick, so it's a really critical thing to keep the joints sealed up. I've heard it put as you keep the roof on your house, you know, you want to keep the roof on the joint. You don't want water coming in tearing things up. It's not only steel bridges where you have a problem. This particular bridge is probably only 30 years old. It's about 500 feet long, and there's only one problem on the whole bridge, and it's right at the joint. So it's pretty high in the air. You know, the joint lasted about 20 years. It got replaced with a silicone system that failed fairly quick. And there was quite a bit of deterioration of the cap. The rest of the bridge looked brand new. So this is one of those areas where we did the maintenance, but we didn't do it good enough to make it last. It comes down to you're either going to pay now when you put the seals in, or you're going to pay a lot more later, because it's really hard working over your head. So I spent some time trying to think about what I wanted out of joints. When I put a new joint in, I really hope to get at least 20 years out of it. It's a pretty major disruption to traffic. It costs a lot of money. It takes time. And I feel like a lot of times I don't need 20 more years out of the joint. I need a little less than that. So instead of tearing the joint out completely, I started trying a lot of different systems that are shorter term. And in my mind, I wanted 7 years out of it to get to where it was worth the time to go out in the field. So things that only lasted 1 or 2 years, I just couldn't keep going back to all those bridges. As a side note, before I start talking about the smaller systems, I did try one sinusoidal reinforcement. I know these are out there. I don't have a lot of good experience to talk about because this is the only one I tried. It was on a precast girder bridge with large diaphragms that you could not see underneath. And the contractor that put it in poured the entire thing shut, so it didn't have a chance of working. It tried to pivot around it. You couldn't see it until it failed. It lasted less than 4 years. So this is a replacement, but it's a fairly quick replacement. And I don't have a lot of good feeling. I mean, I've only had one that failed. I've talked to a few other people that had better luck with this. Moving into the things that I've dealt a lot with, we don't use compression seals on new bridges anymore, but we have a lot of them in the field. If you look at them in the summer, they normally look pretty good because they're smashed shut. But if you go out in the wintertime, when you put chlorides on the road, they leak. We have a lot of elastomeric joints that have lasted fairly well. This particular one is ready for something else to happen to it because the bolts that hold the tray down have sheared off and it's bouncing in traffic. So you either have to rip it out and put something else, or you have to replace the joint altogether. The third example I have on my screen was kind of my borderline case. There's starting to be enough of the armor failure next to the joint that if I could get the money to replace the joint, I would just as soon do that. But if I didn't have the money to do it, I could put some nosing material in one of the systems I'm going to talk about in. So the primary systems that we've used in St. Louis are the XJS or several other versions of that where you have a seal spec and silicone nosing like we just saw in the first video. The Silicoflex gland is 100% silicone gland that was also one of the videos. Evisode is kind of an in-between. I didn't see that one when we were watching, but it's very similar. And then M-Seal, which is fairly new. So starting with the XJS system, this is a elastomeric nosing where you can either put it in a steel tray, you chip out all the loose concrete next to it, you can pour it against concrete, you use a backer rod and you just pour silicone into the joint. What it looks like, you have guys with jackhammers removing anything bad. They sandblast the area to prepare it. Just like the video, you mix up some epoxy, you pour it in. It's epoxy nosing. We've used a lot of different kinds. We've tried Delcrete, we've tried Mcrete, we've tried Wabocrete too. They all have some slightly different ratio of the aggregate, and they all have worked very well for us. You end up, after it sets up, you use foam to keep it straight, you sandblast that back out, and you end up priming the side to put silicone in. So you push a backer rod in, and this is where it gets a little bit more challenging. There's quite a bit of art to getting the silicone right. You have to have 3 times the bond area on the side for the thickness of the silicone in the middle. If the silicone gets too thick in the middle, it won't stretch like it's supposed to and it pulls off the side. If it's too thin in the middle, it tears, and we've had a lot of trouble making that happen. So over the years, we've had a lot of failures of silicone. A lot of different kinds of silicone put down by a lot of different people. We quit using this for the most part unless nothing else works. There are some cases that it is, on a longitudinal joint that doesn't move very much or something little, we still go back in and try silicone. We had a couple that lasted over 3 years. I did a little research to try to figure out why these lasted over 3 years. What I found from talking to the crews that installed them is they actually put them in at very cold temperatures. It tells me that silicone really doesn't like being in tension. So this is a very picky product for the time of year and how to install it. Moving on to the next one. Silicoflex was in the video. I have a couple samples that I'll leave on the table. 2010 was the first time we tried this joint. It is 100% silicone gland, and it glues in with silicone. Originally, there were 3 different sizes. I've seen 5 different sizes now. Originally, there was 1 manufacturer. There's 2 or 3 now that make these products. The first one we did was about a 4-inch joint. We did it in the fall when the temperatures were good. Everything went well. We also did a couple medium-sized ones, and 3-4 years later, it all looked good. We thought, man, we've got this figured out. We like this stuff quite a bit. So we started putting more in with our crews, and we had some contractors put them in too. The difference was we didn't pay as much attention to the time of year. It was a little bit earlier. It was August, July timeframe. It was quite a bit warmer. So when the contractor started working, they ran into some trouble, and when our crews started working, they ran into some trouble too. It was very hard to work with the joint closed up. You would get glue where you didn't want glue. It would glue the gland to the side, and then it would pull off, and you'd have a debonded area. We had one contractor that we didn't catch them doing it, but we did make them replace it later, that actually even trimmed off the bead that holds the joint in. And all of this was because it was the wrong time of year to be putting it in. Now, I really like this system for the large sizes. I have struggled with some of the smaller sizes. I'm told that there are techniques that you can put duct tape down on top of the gland, you glue it all in, you peel it off, and you can do it any time of year. I wouldn't hesitate a bit to use a larger size of this, but the small sizes, I struggle a little just because, if you look up here, this thing's tiny. When you start trying to figure out how you're gonna glue that in, there just isn't much room to work with. Moving on to almost a whole different category of temporary joints. Evisodes, M-Seals, and I even have another one that keep non-compressible material out. We started out looking at some approach slabs that would ratchet. This is by a quarry. This started out as about a 2-inch joint, and it's about 7-8 inches now. So every year it fills up with rock in the winter, it grows a little bit, and it crushes the pavement on the other end, which I don't have a picture of, that they have to repair. So trying to find ways to keep material out, there are joint seals that will do that. Evazode is one of those materials. So you might ask, what is Evazode? It's something along the lines of a closed cell cross-linked vinyl polyethylene nitrogen-blown foam. Or I say it's kind of cheesy. It's really light. And I always struggled thinking that this would work on the roadway because it just feels so light. But we've had really good luck with this. We haven't tested the limits of it because when I go to squeeze on it, it just is hard to push into the joint. It doesn't move a lot. But the places we've put this with pin rotations or small amount of movement, I don't know of any of them that have failed. So I've been pretty pleasantly surprised with it. This is a picture of one close to my office that I look at fairly regular that was put down at least 4 years ago. M-Seal started in parking garages. And I met the salesman at a function in St. Louis. He dealt with sealers as well. We got to talking about joint seals. He told me about what he did on parking garages, and I climbed around several garages with a ladder looking at the silicone and the M-Seal, and I thought, I'll give this a shot. This started out as 4-foot links, and it's a silicone-topped 100% impregnated polyacrylic that it compresses extremely easy. I mean, you can go from 5 inches down to about 1 just with your hands in no time. So like the video showed, it swells pretty quick. We talked to them quite a bit about the challenges that we've had with various joint seals before they even put one in on a bridge for us. We talked about how so many times people just grab a seal and shove it in the bridge if it'll fit. One of the biggest problems we had is the wrong seal getting put in. We also had a lot of joints that would squeeze out the top and traffic would rip them off. So my number one pet peeve is that the joint's too high. I don't have joints fail because they're put too low in the bridge. It's always because they're too high, and when it gets hot, it smashes and it pops out the top and rips it. They listened to what I said. They helped me put one in. They studied pretty hard on how can we help get the right size and the right bridge. So they asked that you send pictures in. They put field cards that you could take pictures of the joint. They asked for the temperature. And then you get the product and you get to install it. So the video went through this pretty well. You clean up the sides, you can glue it to steel, you can glue it to concrete. 4-foot sticks is where it started, but now I think they're up to like 10 and 12 foot, depending on what size you get. They started with 1/4-inch increments, which apparently is something architects like. They like to have 50 different shades of color and 1/4-inch increments all the way along, but engineers want 1 or 2 that they keep on the shelf and they just grab one and shove it in the hole. So they've changed to where now they have longer pieces and they have less sizes because it works in the majority of the applications. So the first one that I put in, I believe it was about 2011, so it's been there almost 5 years now, 4 years, and it still looks good. It wasn't perfect. It was installed a little bit high. They say a 1/2 inch low. I actually 1/2 inch to 3/4 inch low is what I shoot for now so that they don't get ripped out by traffic. Something else that they did, I talked to them a lot about the failures that I do have on joint systems, is always at the seam and at the corner. The corner where you have a sidewalk or where you go into a barrier wall, it's very hard to splice in the field. They came back with a universal 90. They started out saying, how do you want this? Do you want it to drain down, or do you want it to hold the water? And in the city, I said, it depends. I said, if I'm in a rural area where the water can run off, I'd just as soon let it run down, clean the joint out, and then I don't have to deal with it. But if I'm over a sidewalk, I can't have rocks and water falling on people down below. So it's a double-sided piece. You can flip up or down. When you flip it down, the water can't get back to the girder. When you flip it up, it carries the water across. They're a little bit expensive. I mean, they're like $90 or $100 a piece compared to some of the other, per linear foot prices. But to me, this is where I always had the failure, and this has eliminated that problem. So when I asked around some other states, Maine told me that they had some minor debonding, but that they were all watertight. So part of the process to install this is a silicone topping along the edge when you're done. You basically are gluing the silicone topping with silicone to the foam to the edge of the concrete. They started off just running a bead across the top, and now they tell me that you really want to inject it. You want to push it down in and make sure it gets into the foam. While some of it's debonding, they're not leaking. The foam itself keeps the water out. It's just one of those things that bothers people when they look at it. I've also found that some of the seams tend to curl up a little bit at temperature changes throughout the year, but they sit back down and they don't leak. So I haven't really had any problems with it myself, and that's about the same thing Maine said. Iowa used some M-Seal as well, and this is kind of showing the silicone being injected in where it's pushed down below the surface so that it bonds with the foam. You know, Washington State had very similar experiences. They did a little more complicated where they cut the curb and did it themselves, but they were very happy with it as well. So when I think about all this, the XJS for us was very complicated to keep watertight. You know, the Silicoflex, we really have had good luck with the larger sizes. It's trickier when you get into small sizes. It's harder to do in cold weather. The Evazode, we haven't pushed to its limit. We haven't really put it in large movement joints, but it has worked very well for us. And the M-Seal is by far the favorite of my crews to put in because it's so easy to compress and shove in, and you can't get glue anywhere that's going to hurt it. So after I put this together, I found another product called Limtol Silfast XL. And just last month, we did our first trial on it. Now, it's virtually the same thing as the M-Seal that we were just talking about. It's 100% acrylic impregnated foam that has a silicone topping. It's a little bit lighter than the M-Seal, so it probably has a little less acrylic, and the topping is a little bit thinner, but it's still pretty substantial. This one doesn't come pre-compressed. It comes in a 40-foot roll, and you actually just squeeze it and shove it down in. But it appears to be very, very similar to the M-Seal, so there is competition out there if you're looking for multiple joint seals to be able to bid against one another. So hopefully some of that was informative. If anybody has any questions for me, I always try to slip Dilbert in, even if he's just looking at me. So the question was, do we use a lot of strip seals? And a strip seal will replace it with quite a bit of concrete along the edge. So these are like the 7-year fix that I'm looking for, and a strip seal is more like the 20-year fix that I'm looking for. So I do quite a few of them, but I don't do them with my internal crews, and they cost quite a bit more money. They take a lot more time. They're more disruptive. So I have not done the little, I showed the sinusoidal strip seal. When we do it, I think it's a J seal with armor, and it goes back a couple feet into the concrete. So it takes several days. That's the long-term fix. So, any other questions? So, thanks, Don.
Thank you.